Warahmatullahi wabarakatuh. My name is Anas Amirul bin Hamzah. Have a good day. Today I'm going to present about my final year project, MEC601. My project is being supervised by Madam Izdihar Binti Tharazi and co-supervisor Encik Mohamad Firhan bin Morni. There is modeling and optimizing parameters injection molding process. Project summary. Injection molding is one of the biggest industry in manufacturing. This is due to injection molding can produce in large volumes with low cost. Warpage and shrinkage can be occur, therefore we need to optimize the parameters to produce a good quality of injection molding. In this project, response surface methodology (RSM) through Boss backend design technique is employed to optimize the simulation injection molding process. Bottom mount of a keyboard is being chosen as a part in 3D modeling. The material used for the keyboard is ABS. Why we use simulation processes? Because they can reduce time and cost. They also can reduce cycle time, which can be save time. The tools that have been used is SolidWorks and Molded 3D. So SolidWorks is for the 3D modeling and Molded 3D is for injection molding simulation. Talk about the background for the project. The material used is acrylonitrile butadiene styrene, also known as ABS, is being used in this project. Polyfem RABS 90000 UV5 from supplier A. Schulman is being used for the molded 3D injection molding process. Why we use ABS? Because ABS provides good all-around performance for electronic enclosures, usually for computer keyboards. The properties for ABS is high rigidity, good resistance impact, and good insulating properties. Literature review. There are 4 topics that I want to discuss about literature review. Firstly, injection molding processes. Next, simulation of injection molding. Next, parameters and output responses. And lastly, design of experiment and responses surface methods. Injection molding processes. What we need is molding machine, plastic raw materials, and molds. Injection molding process is very complex, involving many fields of science and engineering such as rheology, heat transfer, fluid dynamics, friction, polymer science, and control theory. Injection molding process is usually commonly for plastic parts. Simulation of injection molding. There are so many types of software that can run simulation for injection molding. One of the software that commonly used is Moldex 3D and Mold Advisor. The purpose of using injection molding simulation is to compare the results between simulation and experiment. By doing the simulation, the outcome for the parts can be predicted. Therefore, this can save time and cost due to only going through simulation before the real part is being processed. Parameters and output responses. These are critical for plastic injection molding. Any twist on parameters can influence on product quality such as strength, warpage, residual stress, and many more. The critical parameters usually in common is melt temperature, mold temperature, fill time, and packing pressure. Design of experiment and responses surface methods, also known as DOE and RSM. DOE and RSM predicts the runs that need to simulate injection molding. As example, how many runs and criteria needed to predict the outcome, which in this case, warpage and shrinkage. These two methods is needed to optimize the parameters to have better outcome, which in this case to reduce warpage and increase the quality of the product. This also can reduce time and cost. The cost and time can be reduced due to lesser runs needed for the injection molding simulation. Problem statement. Primary problem for manufacturers nowadays is to identify how to regulate factors that can impact their product. Changes in parameters settings might result some output influence the product quality. They want their product to be high quality and lesser faulty. Objective. There are three objectives that are being used for the project. Firstly, to design a 3D model by using CAD software, which is in this project, I use SolidWorks for the 3D modeling. Next, to analyze 3D model by using finite element analysis software. In this case, Moulding 3D helps to build the 3D mesh. Finally, to reduce cycle time by manipulating parameters, simulate injection molding by using Moulding 3D. Scope and limitation. Scope project. The scope project is 3D model which is being used for keyboard, and the keyboard is being designed in SolidWorks. Next, the material used is ABS. Moreover, RSM design expert, by using parameters, we can see the levels and parameters in the next slide. Lastly, Moldex 3D simulation to see defects, which is warpage. Factors and levels for injection molding simulation. There are 4 parameters is being used, which is mold temperature, melt temperature, injection pressure, and injection speed. There are 2 levels in each parameters, which is minimum and maximum. As we can see, for the mold temperature, the minimum level is 40 degrees Celsius, maximum level 70 degrees Celsius. Melt temperature is 210 degrees Celsius. Maximum is 270 degrees Celsius. The injection pressure for the minimum level is 50 and the maximum level is 100. For the injection speed, we use moderate for the minimum level and the maximum level is high. Methodology. We have some flowchart to show the process of the project. The flowchart. The flowchart starts with study on cases on journals that are related to current research. Next, identifying problems that are related on the current research. Next, selecting and design the component for the research daily in SolidWorks or CATIA. In this case, I use keyboard components. Next, is the preparation for the component is suitable? And if yes, we go into the next step, which is simulation of injection molding in Moldex 3D. The performing analysis is to determine parameters and analyze output responses. If we finally satisfied with the injection molding processes, we go into the next step, which is perform analysis design expert software. Design expert software you can use for response surface methodology to perform mathematical modeling and perform Bose-Bacon method. Next, analysis of variance, which is ANOVA, factor parameters and levels determination, full analysis, run analysis. In this case, we had 29 runs and identifying significant parameters. Next, output optimization. Next, result and discussion. And lastly, conclusion. Dimension model. As you can see on the slide, this is my keyboard parts that we use for the injection molding simulation. The dimension is 356 times 131 times 23 mm. Preliminary result. There are two results, which is Design Expert DOE and Moldex 3D simulation. Design of experiment. This is the result of the design experiment by using Design Expert. As you can see, there are 29 runs based on the parameters that will be being chosen, which is mold temperature, melt temperature, injection pressure, and injection speed. The output responses we choose is shrinkage and warpage. Moldex 3D result. As you can see in this slide, this is the Moldex 3D simulation, and we can see the fill time is 6 seconds. And why the product is not filled accordingly? Because this is just test and run. We can see the video part is not finished because maybe the gate system is wrong. That's why the fill time is only 6 seconds. In this slide, von Mises stresses. Cooling time. Cooling time for the product might difference because the part is not completed. That's all. Thank you.